Hey there, this is lessons 48 through 50 in Algebra 1/2. So here's what we're looking at on lessons 48 through 50. Lesson 48 is called Fractional Parts of a Number or Fractional Equations. Okay, so you say, what in the world is going on with that? Well, fractional parts of a number is just another way of saying something like, let's say, what is 2/5 of 60? Question mark. So in other words, what fraction of 60, or 2/5 of the fraction, how big is that? And so you'll notice that whenever you ask one of these fractional part of a numbers, is you're going to have something is something of something. Now we've talked about that before. In math, words mean things. And so is means equal, of means multiply. So in other words, what is 2/5 of, which means multiply, 60? Okay, well then you just do the equation. Think of 60 as 60 over 1. And so you end up with 2 times 60, which is 120 over 5, which is equal to 24. So 24 is 2/5 of 60. Or I can cancel this and think of this as 5 times 12. 5's cancel. 2 times 12 is 24, which is an easier way to do than to reduce that. But you're saying what is what of what? So in this particular problem, the formula is what equals what times what. Or sometimes you say what of what is what. It's going to be some variation of these two. And what's going to end up happening is one of these answers is going to be a fraction. Okay, so when they say a fraction, so instead of writing the number, we write the fraction. So let's look at, for example, how might you do that? And I shall show you. So this is an example. I'm kind of going on page 158 in your book. If you want to look at this example in more detail, your book has a whole bunch. But it says, here's the question. It says 5/7 of what number is 5/2? See, we don't really care if any of these three things are fractions or not. It's just still something equals something times something. So in this case, 5/7 times, that's what that means, times something. Okay, so times, I'm going to just use the letter x, times x equals 5/2. Okay, and so now I have an equation which I can solve. So I just need to find x. So x is what number? So 5/7 of what number is that? 5/7 of what number is 5/2? I don't know. So we figure it out. Well, if I multiply both sides times 7/5, 5's will cancel, 7 cancels, but I got to multiply this side times 7/5. Okay, then I get x equals, and I can cancel those, 7/2. So 5/7 of 7/2 is 5/2. Okay, that's the answer to that question. So when you're doing these, you're really just doing basic arithmetic problems with multiplication, and all you have to do is set it up correctly and it becomes simple. So I'm going to do practice problem A on lesson 48. Lesson 48. Here we go. Practice problem A. It says, what fraction of 20 is 140? Okay, so you notice this is blank of blank is blank. So I'm going to use an x in the one I don't know. So 20 of x is 20 times x, or 20x. So even though the x is first here, I write it second here, equals 140. Well, this becomes a little bit simpler. X is 7, because 2 times 7 is 14. So I can do that one kind of in my head. Okay, or I could divide both sides by 20, and then I still end up with x equals 7. Okay, practice problem B. 7/5 of what number, I don't know, is 3/8. Okay, 7/5 of what number? I'm just going to put an x for what number. So I have 7/5 times x equals 3/8. Okay, multiply both sides by 5/7. 5s will cancel, so this will become x. I can do this one, same. And so I can't cancel anything. So I have 3 times 5 is 15, 8 times 7 is 56. So the answer is 7/5 of that thing is 3/8. Okay, last one. C. 5/13 of 26 is what number? Okay, so again, bank of blank is blank. So 5/13 times 26 equals what? Well, 26 is the same as 26 over 1. So I can reduce this as saying this is 13 times 1, right? So 13 times 2. So 13s will cancel, and then 5 times 2 is 10. So 10 goes here. That's the answer. So 5/13 of 26 is 10. So blank of blank is blank. You have a bunch of problems. You just have to get good at solving those. That's lesson 48. Lesson 49, switching up to geometry again. And that is surface area. So let me review with you. Surface area. Area is always going to be something squared. Okay, so remember that. If your answers depends on what it is. If it's feet, then it's feet squared. If it's whatever it is. Simplest one to look at it is if you have a box and it's a regular old box, and I want to know the surface area. What I'm looking for is what is that area plus the one on the other side, this area, one on the top plus the bottom, and then this area, the front and the back. So you'll notice it's basically the side times 2, the front times 2, and the top times 2. Okay? And that's what you do. So it's your side times 2, and the front times 2, and the top times 2. That twice, this twice, this twice, if it's a nice box. But what if it is not a box? What if it is a funny key shaped, like this, a prism? Well, in this case, it's the front and the bottom. So in other words, it's I'll call this the front or the top times 2. That's that. Plus, it's this plus this plus this. That's the perimeter times this, which is the height. So the perimeter of the front times the height. And that, the height would be h, or how high it is. So let's give you an actual example. So let's say, for example, you have one of these that is 9 by 12 by 15. Okay, and it is, let's say 20 deep. Well, the area of the front is 9 times 12 divided by 2. Length times width divided by 2. Okay, which is same thing as 9 times 6. 9 times 6 is 54. Okay, so it's 54. And I'm going to say these are in feet. So it's 54 square feet. That's the front. Okay, the back. Plus the perimeter, 9 plus 12 is 21, 31, 36. 36, that's perimeter, times 20. Okay, so I have 108, that's 54 plus 54, plus 36 times 20 is 720. Okay, so my answer is going to be 828 square feet. Okay, so it's the perimeter of the side times the height. So I said height because I had to say some word. Um, and it'll make more sense if I were to draw this like this way. And then it was, okay, this case I would have the perimeter of the top times the height. But when I lay it down sideways, height doesn't really make much sense, but it is. It's whatever funky shape it is, twice, then the perimeter, this plus this plus this, times the height. Okay, that's going to be what you're going to do on lesson 49. Okay, lesson 50. Lesson 50. Lesson 50 is scientific notation. Okay, what does that mean? Well, let's see. Scientific notation is basically a different way of writing numbers. When you have really big, scientific notation is used for big numbers and small numbers. So let's say you were looking at the weight of an atom, 3.1 times 10 to the, or weight of an electron, times 10 to the minus 31 grams. That's how much a electron weighs. If I were to write that out, it would be 0.00000000000 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 31. 3.1 times 10 to, that's what this would look like. So if you look at it, how do you write this number instead of this number? Well, it's much better to write that number. Yay! We want to write scientific notation. In other words, it's just taking a very, very small number and making it so you can read it a little bit better. Or taking a really big number, like for example, how fast did the speed of light go? Well, speed of light goes 3 there we go, this many meters per second. Well, it's much easier to write 3 times 10 to the 8th meters per second. So big number and small numbers, we don't want to write all those zeros. We put them in scientific notation. That's the why do we do it. It's really no more complicated than that. Big numbers and small numbers, we put in scientific notation because there are lots of things that are very big and lots of things that are very small. When you're dealing with chemistry, things are very small. When you're dealing with things like astronomy, things are really big, and that is the deal. For the most part, we don't do a lot of scientific notation on things that you can just measure with a ruler. So here's how it works. If I had a number like 0.0534, how would I write that? I would write it as 5.34. So let's start with this part. Whenever I see a point and then something, or 0 point something, and it's in other words, it's smaller than 1. It's 0 point something. What I do is I look for the first number, in this case that's 5, and I write it. And then I put a point and I say 3/4. And then I say 10 to the times 10 to the, and I count how many spots that is. 1, 2, 10 to the negative 2. That's what that means. So it is 5.34 times 10 to the negative 2. That is scientific notation. So let's try another one, 0.003657. Okay, I look for this. So it's going to be 3.657. And I go 1, 2, 3 times 10 to the negative 3. That's what that means. And so think about it, tens, hundreds, thousands. Okay, so that's a thousandth. Okay, so this is 3.65 thousandths. That's what that means. 3.65 times a thousandth. And that's how small that is. So if I have a number like 42.87. Okay, in this case, this number is bigger than 1. So I look at my first number, and I write it as 4.287. And this times I write it 10 to the, in this case, how many points from the decimal? It's only 1. So if it's a number bigger, notice this number is a positive. If a number is smaller than 0, notice these numbers are negative. So let's say I have 42.87.000.000. Okay, I would go here and I'd say it is 4.287, and I keep going until I run out of numbers. And once I get to the zeros, I'm done. Now I just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the positive 9. Got it? So if I see a number and I want to change it to scientific notation, I rewrite the number with the first digit and then put a point after it, and then count how many dots from 0 to that number, or on that side of that line I drew. Okay, so that's how you go from there to there. Now, let's write it backwards. So if I start with a number, I can write it in scientific notation. What if I start with scientific notation and I need to write the number? So let's say I have 3.2 times 10 to the 5th. Okay, so this is going to be 3, 2, think of it this way. 10 to the 5th means it is 5 spaces. So that my answer is 320,000. Okay, 3.2, and I just count 1, 2, 3, 4, 5. Okay, 2.64 times 10 to the 3rd. Okay, all right, 2640. So that's going to be 2006 answer. Okay, again, there's 1, 2, 3. If this is a positive number, that means it's going to be bigger than 0. What if I have 5.17 times 10 to the negative 6? Well, 517, and I need 6 spaces. 1, 2, 3, 4, 5, 6. So 0.0000517. So that's what I do, is basically take that decimal point, make that as my line, and I have that many spaces on this side of it. You with me? Hope so. That's the homework. That's lesson 50. And I will see you next week.